So likewise, the drum, we have never been as close to launch with Athena. That's true. That's a fact. Okay. Thank you very much for inviting me. First of all, I must apologize for not being more present at this fantastic meeting. I have some duties related to XIFU, but today I'm going to report on where we are with Athena as we are right now entering a new industrial study phase. The path to Athena was supposed to be straight, but the path from XMM to Athena was supposed to be straight, but in 2022, we got stopped and we went to a loop of reformulation of the mission. And today, in 2024, as we start a new era for the mission, I can say that the path forward exists. So I'm going to tell you about where we stand after the completion of the reformulation phase. How did we make it fit the bill? How was the flagship status of the mission preserved? And where do we stand in terms of performance and how the new XIFU looks like? I must say that these are typical questions that are asked to me, and today I'm not going to repeat the same presentation about the Athena Science Objective, but I'm going to focus on how we make it back again in the science program of ESA. So I start my talk with the conclusion, then you can go back to your email or distractions. So the takeaways is threefold. First of all, in June 2022, we got stopped. We were asked to find a solution for this mission to fit within what ESA called at the time an acceptable envelope for the ESA science program of the order of 1.3 billion euros. So we went back to the drawing board and we completed successfully this reformulation phase in November last year, both technically, programmatically, and scientifically, because the mission, as we reformulated it, was declared flagship by the science redefinition team. And this flagship status was endorsed by the Science Program Committee of ESA, which recommended to start as soon as possible an accelerated phase AB1, in which we are just entering as I speak. I must say that when we were stopped, we didn't know there was a solution existing. It was not granted that we would succeed, but I think thanks to the engagement of the instrument consortia, and I must say in particular XIFU, because as you will see, XIFU was dramatically affected by the reformulation, but also the international partners and the ESA study team, we made it successful. That's the first part of my conclusion. The second part of the conclusion was that this reformulation affected primarily XIFU. There was also some impact on WFI, but it was expected that XIFU would suffer the most because it was driving the previous design of the mission. Now we are relying on passive cooling, which enabled to simplify the cooling chain. Basically, we have now one powerful cooler, which goes from 50K to 4K, which is provided by NASA. And in fact, it was also possible by transferring back many of the responsibilities that we had been forced at the time to offload to ESA, transferring those responsibilities back to the XIFU consortium and to the international partners, namely NASA. This is the cryostat and the cooler. The third conclusion is that to survive, you must drink, but not too much. So we have a clear path. I tell you, this is true. We are starting now the industrial activities. We are doing this pre-study phase at the moment, the kickoff will be sometimes in April 2024. There will be a new Athena Science Study team appointed. We have to work very hard in ramping up our critical technologies by mid-2026. It seems maybe far for you, but for us, it's tomorrow. And of course, we understand that the higher our technology level is at adoption, the safer it is afterwards. And we are targeting a mission adoption in 2027. Adoption means inscription in the ESA Science program for good and the launch of the big industrial contracts. After that, I think we cannot stop. We cannot stop the mission. The launch date today is 2037. Although yesterday I had a meeting with the executives where 7 became 8-ish, which is not necessarily a good thing. And we are after a development time of 9 years. But the message for you is that we have a credible path forward for Athena, and we decided to celebrate this the success of this reformulation by the release of an XIFU cuvée, which is open for sale for the XMM to Athena members. There is no doubt. As I speak, we have sold 1,302 bottles of wine within the consortium. So you may consider we have a large consortium, or we are heavy drinkers, or both. And as you know, sobriety is good, but with moderation, of course. So now you can go back to your routine activities, but for those who will stay and ask a question on the content of what comes afterwards, there is a gift. And you have to guess what this gift is. The first one was the question. Okay, in the meantime, everything was fine. We were reformulating heavily the mission, Athena, and to whom benefited the crime. It's very easy to guess. LISA was adopted in the ESA Science program early this year. So it is good. LISA is out of the way for us. It was always in the competition, looming in the competition. Now they are before us. That's fine. There are two problems which raised a lot of concerns on our side. First one is that the cost at completion of LISA is much larger than anticipated at the time we started the reformulation, because the same cost cap should have applied to both missions. And the other worrying thing is that the technology readiness level of LISA per the SPC paper is not great. So when we saw that happening, we were worrying that this would have an impact on Athena on the long run. So we raised many concerns to our SPC delegation, which raised the issue to the executives of ESA, and asking that there are some guarantees that the schedule and the adoption of LISA would not impact the schedule of Athena. And the ESA executives during the adoption process, which was not a very smooth process according to what we have been told, put the guarantee that the Athena schedule should not be affected at first order, at least for the adoption. So we are waiting now for a big paper, the long-term implementation plan of ESA, which should come in for the next SPC meeting in March, where we should see definitely Athena in the landscape together with the M7 mission. And again, I've been told no later than yesterday that after that, it's very, very unclear what will happen. But for me, the adoption of LISA makes LISA out of the way. We are the only remaining mission, large mission to be adopted. And the good side is that by raising our concerns, we saw that all the delegations were supporting Athena, and they didn't want Athena to be impacted by LISA. So again, we are putting all our efforts now to get this mission adopted, and this is the prime goal for us. Alex, who is not Didier, asked me, how did you make it fit the bill? Because it's incredible, indeed. We went up to 1.9 billion euros. Now we are back to, in economic condition, 1.3 billion euros. And how did we make it fit the bill? Basically, touching on many things, but most of the things where ESA was involved or industry was involved. So first, we reduced the mirror diameter, removing the two outer rows of the mirror, which has an impact on the 1 kV area, effective area. We removed the onboard metrology system, which is not needed anymore because the angular resolution was relaxed to 9 arcseconds. We removed the particle radiation monitor, which will have an impact on our capability to monitor the background and meet the requirement on the background reproducibility. We reduced the field of regard to ease some hardware in terms of solar array and mirror sun shield. Of course, we simplified the science instrument module. Basically, ESA is not contributing anymore to the payload. They are just providing us with 50K, 55K interfaces, thermal interfaces through V-grooves, which are under the prime responsibility. They move back the cryostat of XIFU to the perimeter of the consortium. We had to find a partner to do that. Spain stood up and said, we want to deliver it for you. They removed all their contribution to the active cooling part of the instrument. Now we replaced all the European, Japanese cooler by one single cooler from the US. It's a 4K cooler, where, of course, you know that a similar 4K cooler is working very well on GWST. WFI was also affected, had to simplify some thermal interfaces, and the thermal control system of WFI was taken back to their perimeter. And one thing which is very important also is the assumption to fit the bill is that we raise the TRL level of our technology by 5 to 6 in mid-2026. And there is another thing which is not said here, that the development time of the mission was constrained to be 9 years instead of 12 years. So this is the time when we have the big marching army from industry working on the spacecraft, on the satellite, both at engineering and flight model level. And so we spent 12 years in the past, now 9 years. Compresses everything and makes, of course, less people for a smaller period. So from Athena in 2022, as we were peacefully moving to adoption, it should be known that we had started the adoption review of Athena back in 2022 when they discovered that there was a cost issue. So the reference point could be Athena 2022, not Athena 2024. We didn't change the orbit, it's still L1. We didn't change the launcher, Ariane 6.4, but we were granted 1 year of observing time, more observing time, to compensate in part of the reduction of, for the reduction of the mirror effective area by the removal of the two outer rows. In terms of science performance, as I said, we cut down, the ESA cut down the mirror, basically from 1.4 square meter at 1 kV to 1.1 square meter at 1 kV. No impact on the high energy response because it's the inner mirror modules which focuses the higher energy X-rays. The angular resolution was descoped from 5 to 9 arcseconds. ESA considers today that they have demonstrated at prototype level 8 arcseconds. They ask us to descope the spectral resolution of XIFU from 2.4 to 4 eV. This was a big fight, but we gave it up because we understand that it could ease the verification and relax the schedule, in particular at the prime when we integrate the instrument on the satellite. But still, we are stubborn in XIFU, and we want to keep an internal design goal for the engineering team to 3 eV. And we believe we can make a 3 eV provided that the environment is provided by the spacecraft is not too bad. The field of view of XIFU was downscaled from 5 arc-minute equivalent diameter to 4 arc-minute equivalent diameter. It's a reduction of the number of pixels by about a factor of 2, less than a factor of 2. It simplifies the readout and, of course, reduces the heat loads on the cold part of the instrument. We managed to preserve the field of view of WFI. That's good. And the field of regard, which is critical for TEO observation, for instance, was this downscale from 40% to 34%. The response time remains less than 12 hours for 50 kiloseconds observation for the 67 of pursuable targets. We have currently 2 TOs per month in the science requirement, preliminary science requirements, but we may be able to go up to 5 arcseconds. In terms of spacecraft resources, everything fits with margin, both in terms of mass. In 2022, we had a 7.5 ton spacecraft, now 6.8. The Ariane 6 capability is 7.8 tons, where we have lots of margins. The instruments have been also reduced in size. We had a 800 kilogram instrument for XIFU. Now we have a 450 kilogram instrument with the NASA cooler included for about 100 kilogram. The V grooves are provided by the spacecraft. They are outside our perimeter. WFI was not touched, but they have to take on board the thermal control system, which was in the ESA perimeter. And in terms of power allocation, we are safe by a large margin, and this will have also an impact on the size of the solar panels. So let's look at the bright side of life. We have a flagship mission ahead. This was stated like this, despite these cuts. I will explain you my read of the cuts, but this was the final statement from the science redefinition team, which was presented to the SPC, which recommended to continue with Athena. Basically, it said that with these cuts, the performance of the mission were not too badly affected on preserving the flagship status of the mission. Now, I think we understand why, because when you look carefully, I mean, you take a bit of perspective on the cuts. I think they were moderate in many places. Some performance were preserved. The mission lifetime was extended, which is good. And all the breakthrough capabilities were retained, including, I mean, especially for XIFU. And something that had not changed is that in this time frame, Athena will still be the facility matching the performance and the capabilities of other large observational facilities that will be operated at the time. And of course, as Olivier said, at the time where time domain astrophysics, astronomy, and multi-messenger astrophysics will have ramped up clearly. And of course, Athena is building on a very large community. You are part of it. We keep building this community behind Athena, behind XMM, and of course, Chandra, and hopefully soon, CRISM. So the science case was very much untouched, to be frank. We will do less, of course, because we have less capabilities, but we will still be able to do a lot of the original science goals that we put in the white paper back in 2013. We want to understand how black holes work. We want to understand black hole outflows, how do they affect their surrounding. We want to understand the feedbacks in clusters everywhere. We want to understand where are the baryonic reservoirs in the universe, how do they evolve, and why those baryons are hot and stay hot. And 2 other science objectives were promoted. What is the equation of state of dense matter in neutron star, and what are the explosion mechanism of supernovae remnants? Nothing really new, to be frank. That's why I don't give you the usual presentation, but I think we had a better accounting of the changes in the scientific landscape. And of course, reducing the capabilities means that the samples of objects which we were planning to observe will be reduced. But hopefully, XRISM will come up. It has come up, and it will open a new field, high-resolution spectroscopy, spatially resolved. And I believe that a new community is going to build about this, and we don't know yet where this will take us. But what we know is that it will likely call for a new instrumentation. And I want to show you that XIFU is really perfectly suited to bring this new capability, following up on XRISM and especially the Resolve spectrometer. As you probably know, there is an issue, instrumental issue with Resolve at the moment. They are working on it. They have not opened the door of the cryostat, which means that they cut the observation below 2 kV is cut. So if we compare the response file of XRISM with the one of XMM, of XIFU, you can clearly see that this range of energy will be extremely well covered with XIFU, while it will not be seen by XRISM Resolve. Let's hope that they open the gate. They are working on it at the moment, I know. In terms of performance, basically you can play with figure of merits. This is weak line sensitivity. This is line shift detection, where basically you fold in a clever way the effective area with some scaling factor, and the spectral resolution we gain in both in effective area and scaling and spectral resolution. And basically for weak line detection sensitivity, you will get to the same signal ratio with XIFU than what you get with XRISM Resolve, with an observing time which is 1,000 times less. That's one way to see this figure of merit. And to measure a line shift at 7 kV, you will need or 6 kV, you will need 100 times less time with XIFU than with XRISM Resolve. And of course, we will gain in spatial resolution. I am done, yeah. And we will gain in spatial resolution. This is a nice image simulation of Perseus seen with XRISM and seen with XIFU. And as you can see, I mean, we will have both many more pixels and many more counts per bin because of the larger effective area. For WFI, same thing. I mean, good, same thing. They have carried out some simulations. The number of sources per observation will still increase compared to XMM, of course. We will not go as deep as we had thought at the beginning, but we will still have a huge grasp and a huge improvement in survey speed. Of course, the largest impact for WFI was on the IZ AGN, which is going to be harder to make. Although I think there are interesting prospects based on the JWST results, which show that there are a lot of AGN very early on in the universe. So in terms of XIFU, as I said, we are relying on the big change for us was in the cooling assembly, and we are relying on V-grooves, and that's these V-grooves are shown here. On this. It's very slow. They are shown here, and we have basically a 50K interface, and from 50K to 4K we go from with this big US cooler, and then we go from 4K to 50 milli-K by double stage ADR. And one of the things we have to do is to deliver an integrated instrument to ESA. So all this thing is under our responsibility now. And as I said, we reduce the field of view, we reduce the readout electronics, but other than that, there were no big changes in the overall electric avionic architecture of the instrument, we preserved almost everything else. As in the reformulation, we knew that something will break. Japan left the consortium, US, Spain, and France had to take more responsibilities. Okay, so my conclusion for good. We have a path forward. We are earlier in 2024, starting industrial activities. Big milestone for us, 2027, adoption of this mission, and then implementation in 9, 10 years, and a launch in 2037. Hopefully, we will get there, but the big milestone for us is 2027, and we will do, at least XIFU, we will do everything not to put any constraints on the adoption date. Thank you very much for your time.
Thank you. Questions?
Question gift. Hola. You have to guess what it is. Huh?
Oh, I have to guess what it is. I thought it looked like a bottle of anthrax, actually, but I'm hoping.
It is related to wine. But,
Okay.
What else can it be? What else can it be?
Yeah. It's a philosophical question, this one. So, I mean, as you might guess, Didier, I'm thrilled that the new Athena or whatever we're going to call it, Bob, is actually happening. 2038. I mean, I like to pretend I'm still young. I'm going to be closing in on 60 by then. How do we ensure that we have a new generation of people who are still excited in, over the next 14 years, we continue to generate a generation of enthusiastic and skilled X-ray astronomers, so that by the time this absolutely game-changing observatory launches, we have a generation of postdocs and new lecturers and so on who are in a position to do world-changing science with it. You've got as long as you want.
Well, I think, as you have to keep, for me, the way I see it is, it will take I think when this mission gets adopted, I think the momentum within the community will get back, and there will be, I see the community lining up behind the mission when it's adopted. That's the first thing for me. Then, of course, keeping XMM running as long as we can is a great thing for this. And I think for spectroscopy, although Prism Resolve is, I hope they open the door, but although it's not, even if they don't open the door, they will, my bet is that they will discover a new world which will call for more data, more observations, and in combination with existing facilities, I think CRISM will also revolutionize the field. And I would tell the younger generation to look carefully at what CRISM is going to do and be ready for when we start really preparing the scientific exploitation of Athena in the early 30s, when all these things will unfold. But clearly, I will be old. I will be in retirement hours when we launch, but clearly we do that for the younger generation, because I think there is still room for observing the X-ray universe with this type of machine and make a lot of exciting discoveries. I think I'm happy to say that the reformulation did not put too much cuts on the performance of the instrument. I tell you, XIFU, we were really under fire, and we managed to preserve a 4-minute field of view, the spectral resolution of 4 eV. That was tough, but we knew that this was needed to keep the flagship character of the mission, so we did it this way. Thank you. That's yours.
Anyone else?
I have other things, yeah, Matt, of course. It's high technology, I feel.
It's a stupid question, probably, but tell me you don't have a gate valve equivalent on the front of
We do.
XIFU.
We do.
Okay.
We do. There are Belgian colleagues in this room. it's on their side, huh? That's, but
Okay.
be sure that we will make sure that we have a very redundant
Okay.
system. But they had, it seems to be unfortunate what happened to them, huh? It's not, it was not predicted, I think, the way this thing happened. And but clearly, I mean, we, as you know, we have a lot of US colleagues, part of XIFU. They are heavily involved in resolving the result. That's the same team, basically. And it's very interesting when they come to our meetings. The first thing they say, well, have you thought about heating the door? Have you thought about what is surrounding the door? And they're asking these questions because they know what is behind. But of course, our Belgian colleagues have some heritage. They have already built the doors, a similar mechanism for air shell. But you know, yeah, of course. But the door will still have will still have holes, so that it would be better if it opens indeed. But still, it will open. We will be able to detect X-rays with the door closed.
Thank you. Let's thank Didier again.
Probably.